are starting to get some sort of response committee to try to convince Exelon not to shut down their plant. Which is interesting because this is, you know, what I think should be the response of the public to a nuclear plant shutting down is we need this energy, we need these jobs, we need this economy in our state and local area. But it is unfortunately not always the response that occurs. California has been shutting down their plants left and right over the last few years to the support of the public, unfortunately. So this I thought was really encouraging local response. So I think Illinois is pretty fond of their nuclear power plant there in Byron.
You think California is going to change their tune now that
I don't know. California just does its own thing so often. But for me, they're really hard to try and guess because you have some pretty incredible learning institutions, right? You got Berkeley, you've got an Ivy League school there. You have a lot of very smart people, but for whatever reason, I feel that a lot of the policy information that they get, they miss a piece between theory and reality. And I don't know if that's because the rejection of reality is that we just haven't set government support up to make that a reality. And so California has this little experiment where they're trying to say if the government supports it, the structure will come, which in some cases, I mean, that has been true in the history of like the US Industrial Revolution. There were certain things that were supported because there was government intervention. Like you can look at the media and entertainment industry and why we have barcode scanners instead of another system. I forget what the alternative was at the time because it never went anywhere. But barcode scanners were essentially put in place because the government, the USDA started using it. And that's why grocery stores started using it. And that's why we have barcode scanners. Like USDA did that, not by purposefully regulating it, but they just started using that system. And so it was easier for everyone else to go with what it was established, right? So that definitely happens. Barcode scanners are maybe a very small example compared to like energy policy. But I don't know. California sometimes just really befuddles me. And you know, like Obama's energy policy, where he had that all of the above strategy, and he drove the cost of gas up so high, like that was a very purposeful decision in order to make alternative energy options way more competitive. Because gas is so cheap right now with just the way our capitalist-driven economy tends to work. If there is a cheaper option, that's what the consumers do. That's therefore what the distributors do, right? And so there was not competition to make it economically viable to move into some of these alternatives, right? And so Obama's energy department was essentially instructed to work with different organizations and like, we're going to keep pushing the price of gas and oil up by regulating it and restricting it so that these others have a chance to compete. And then we can take away this regulation and hopefully the free market will now have several options that are competitive and we can move away from both foreign oil and the polluting gases, right? And so that's not a bad strategy. You may disagree with it depending on where you fall on the freedom spectrum and the ability of the federal government to interfere with free market, like just personal politics there. But it wasn't an unreasonable strategy to accomplish what his stated goal was, right? California, I haven't seen the logic to their approach. I don't know. Because that, you know, you may or may not agree with what Obama did. I can at least see the logic. California keeps building solar and wind plants, but they see on their grid that they aren't able to meet their demand. And they can't get that baseload power. So they're either going to have to buy it from somewhere, which is going to be nuclear or gas or oil, or they're going to have to put one of those in themselves. And it's like they're just like not looking at that corner of the problem. From my perspective, I don't know. I'm not perfectly informed. Maybe I'm missing something, but. I mean, they can't keep lights and air conditioning on right now. So you're going to plug in your cars, and it's going to be more of the peak hours, right? Because you're going to get home from work, turn on your AC, turn on your oven, turn on your lights, turn on your computer, turn on whatever else, and plug in your car all at the exact same time, right? Within a very few hours. There's going to be a huge peak demand that's going to come on very quickly. So I feel like they would have to. But I don't know. I don't know what their plan is. I haven't heard that they have a plan. I mean, I would imagine that short term, to make that happen, they're going to have to buy energy from another state that produces in excess because they're running into shortages. And so they're probably going to end up buying from either all the natural gas we have up here that is in pretty close proximity to transmit to Northern California, or they're going to have to buy from Palo Verde in Arizona, which is pretty close to transmit to Southern California, or they're going to have to come up with something else. They shut it down. They're decommissioning it. Diablo Canyon. Yep. It was earlier this year or last year. It was recent. But yeah, it's shut down. And Greenpeace and a whole bunch of anti-nuclear groups had some big victory protest celebration thing when they announced that. But Diablo Canyon just was having, it was too anti-nuclear. Everything they tried to do to extend and repair and get some relief was just blocked because the NRC has a public hearing system. Nuclear power, you have to have local support or you really get hamstrung. Yeah. I don't know. I kind of feel like what I've seen is that they'll end up blaming the federal government for not also embracing those programs and not having enough growth happening in solar and wind to make up for the needs. That's kind of been the logic I've seen out of the legislators in California. But I know that they have very smart, informed people that work on their advisory committees. So I'm not sure where the disconnect between the scientific information and the legislation that keeps coming out of California happens. And even then, a way to store it, a way to provide power when the sun is down, right? Because we don't have the battery technology right now to do that for the population of California. Because remember, there are more people in California than all of Canada, right? So the governor of California technically governs more people than, is it a prime minister in Canada? Yeah, than Trudeau in Canada does. And so you have just a lot more needs that are not being currently met. So yeah, it'll be interesting. I mean, Idaho and Utah are also in kind of a similar energy crisis at the moment as well, because in Idaho, we have traditionally had extremely cheap energy because we've had all hydroelectric. The majority of Rocky Mountain power comes from dams that were built 100 years ago by the Corps of Engineers, and we haven't had to put new cost into new construction. And then we've been able to buy a lot of natural gas just because of the area we live in. But we can no longer expand our hydroelectric. We can't build any more dams. We've tapped out all the places you can get electricity in the rivers here. And so as our population grows, which I think COVID is going to see a tremendous exodus from large cities and into smaller population areas. It's already started for January to September of last year compared to almost that same, we're not quite at the end of September, but almost that same period. The number of people who moved to New York last year is 25% more than those who moved there this year. And the number of people that moved to Salt Lake City is 20% more this year than it was last year, right? So places that are, and I mean, even Salt Lake City is more populous than the entire state of Idaho. So, you know, still big comparisons, but I think you're going to see a lot of people coming to Boise, Pocatello, Idaho Falls as they respond to how difficult COVID's been in the bigger cities comparatively. And so as that population increases, and then, you know, just in general, more people, the Mormon culture, as families grow, they tend to not move away. And so cities tend to grow in this area a little bit faster than other places because family is such a cultural value around here. So I think that UAMPS is kind of the solution, right? Where Northern Utah and Southern Idaho are saying, yeah, we'll build this new scale plant and we'll provide a new source of power. But I think some counties in Idaho have been hesitant to sign on until they see how much the expense is going to change, just because our energy has been so cheap. And that's going to be hard. Based on how everyone in Pocatello responded to just our houses being appraised more correctly when they've been undervalued and undertaxed for the last probably decade, having suddenly nuclear power to pay for instead of hydroelectric, I think everyone's going to lose their shit again. Okay, sorry for that rabbit trail. It was just interesting current events. Okay, Caden, you online?
Here.
Okay, great. Joe's here. Marcus? Great. Porter's here. Cattell, Lynette, Sam? Great. Jack's here. Kyle? Great. Okay. Amber's here, Jennifer, and Haley.
Here.
Great. Okay. So we talked about valves last week. We're going to talk about valve actuators today. And then on Wednesday, you guys will have lab. Evan hasn't said anything to me, but I would just assume it's going to be your two separate groups and just go directly to his area. Don't come here first. But I will let you guys know tomorrow or at the materials class if that changes. And I still haven't heard from the grad student in the materials lab, so I don't know what happened to him this morning. I sent an email, the secretary called and texted him. So maybe something personal came up, but I'll let you guys know if we get that rescheduled. It will almost certainly not be Wednesday, but I might try for Friday. So. Yeah, Jennifer. It's still not ready, so no, we'll be in here. I talked to Evan, and they have the structure for holding the screens ready, but it's not installed. So I told him that we really need to get the screens up so we can see them and use them and have just a little bit less running between screens on this. But yeah, we could see. I don't know where Evan keeps them. I'll have to ask him. But yeah, and then we could get it set up and just get it up and running, and that would be great. Okay, but components. Can everybody online see the presentation?
Yeah, I could see it.
Okay, great. All right. What is a valve actuator? How do we operate and utilize them? Types, and then some valve failure positions when our actuator doesn't actuate. And I am supposed to be in a meeting at 11, so I might go a little fast just so I can try to not miss that. I didn't expect us to have so much great conversation about California. Okay, so a valve actuator is the mechanism for opening and closing a valve. Some type of actuator is necessary to allow for the positioning of a valve. So you have some type of actuator on every single valve. Some of them might just be the simple mechanical one, right? Where you turn the wheel or rotate the handle. That's still an actuator, okay? Depending on if it's a throttling valve or not, they can either vary the size of the orifice that the fluid is going to travel through, or they can shut or open the valve, okay? They're selected based on a number of factors. Torque necessary to operate the valve. You don't necessarily want the strength of an operator, especially if that valve is in an inconvenient position where you can't really like put a tool on it and stand back and use your whole body weight or your, big muscles. Maybe it's underneath something and you can only just reach it with your hand. You don't want the torque to close and open the valve to be representative of the force that the water's flowing through, right? If you have a very large primary coolant pump or primary coolant pipe that like some of us could crawl inside of, right? They're big pipes. That's a lot of water. That's a lot of pressure. That's just a lot of weight of water, even if it isn't flowing and exerting pressure. So some types of valves are designed so that your actuator has a much lower torque required to move that orifice and close or open or throttle that flow, okay? Sometimes you have to have automatic actuation. Your emergency core cooling systems will start automatically upon receipt of certain signals. If you have a large break loca and you have pressure dropping because water is flowing out of a burst open pipe somewhere, the ECCS is not going to wait for you as the operator to say, okay, I need to open this valve and this valve so that my emergency water can dump into the core. They're going to do it automatically. And in fact, some of those systems try to avoid even having a valve because a valve can get stuck, right? So some of them are completely passive systems. They've got a tank of water above the core. You've got a pressurized nitrogen bubble on top of it that's constantly pushing on that water. But the pressure of the core is high enough that it keeps that water up in there. And as soon as the pressure in the core starts dropping because your water's flowing out, the nitrogen bubble just dumps that water, right? They want to cut a valve out of it. But if you have to have a valve for some of our high pressure injection systems or our low pressure residual heat removal systems, you're going to need to have that open automatically, okay? Type of control system. Some of them might be connected to your control room console and have output. That's very important for other systems. Some of them might be more isolated auxiliary systems. And depending on where that control is, you might have different types of actuators. One of the issues that ATR has, it's one of their aging issues, and they have an aging committee to work on this, is that a lot of the wires for the electrical signal that run through the plant are old. They have a lot of noise. They have a lot of length that signal has to travel where it can degrade. And so they don't necessarily have the most reliable electronics in every part of the plant. Sometimes they have issues and they repair them. Like it's still a safe plant, but electronics can degrade over time, right? Especially if they're old. Like we talked about, they just removed the vacuum tubes from the control console of the AGN reactor here on campus. It's really old technology, right? So depending on the type of control system, if you have an older control system and you can't update that, you may not necessarily want the most modern electronic valve actuator, right? You want something compatible with what you're looking at and that deals with the known inconsistencies or variabilities within that system as well, right? And then reliability versus safety issues. So reliability and a plant reliability program, which almost every nuclear power plant and nuclear facility has some version of, essentially is saying that you have to be able to have systems operate when you need them to. When it receives an automatic signal, if your valve actuator doesn't take that signal and actually open the valve, it's not reliable. And a lot of money goes into providing redundant systems so that even if that occurs during an emergency, the plant can still do what it needs to do. But the best answer is to just have a reliable system in the first place, right? So you don't have to go through multiple backups to get done what you need to. And so certain valve actuators and valve actuator combinations may be more reliable than others, and you're going to lean towards those choices even if there other obstacles you have to overcome. Like they're more expensive, they're more difficult to maintain, they're older technology, whatever those considerations are. If reliability and safety is more favorable, that's going to be your governing decision factor. So we've talked about manual, hand wheels, and levers, right? Some other common types that are called out in the DOE handbook are electrical motor, pneumatic solenoid, hydraulic piston, and self-actuated, okay? All of those, except the 2 manual, are adaptable to automatic actuation. But you're still gonna see manual as the most common type of valve actuator. This is why valve lineups are such a big deal in an operator's world, because even though there may be specific valves that need to be automatic and have such a large volume of water at such a fast flow that you may put an electric motor or hydraulic piston into it just because it requires so much torque, even when designed to reduce torque through the actuator, you're still going to see manual valves everywhere in far greater numbers. So even though you've got automatic actuators and you've got a whole host of operational and maintenance issues with making sure that those receive their signal, do the correct action when they receive that signal, and then are able to be correctly giving the status of their configuration to your control console, you're going to have to rely on a whole lot of valve lineup checklists and system walkdowns for most of the rest of your systems, and or knowing what mode you're in and what is normal output from that system in your control room, because it's really easy to misalign manual systems because they're everywhere. Okay. So here's just a little bit on how they work. Okay. Manual actuator, kind of duh, they use an operator to position the valve, right? That mechanical advantage might be how they address the reduction of torque through your manual hand wheel or lever for a system that is dealing with a lot of pressure or weight of flow, okay? Electrical motors, almost always they have to be reversible, right? Because you're not going to have many scenarios where you close a valve and you don't need to be able to reopen it at some point, right? So essentially they connect directly to the valve stem, and as they spin that electric motor, you're going to have a gear train that is going to reduce that rotational speed in order to increase torque. And a lot of times you're going to see these on very heavy, large valves that you need to be able to throttle the flow, because you can directly put in a number of steps into the motor that corresponds to the amount of throttling that you're able to do on the valve, right? So they're very easy to precisely control how much you open or close a valve. Pneumatic actuators use air pressure on either one or both sides of the diaphragm to provide the force to position a valve. So as that pressure on one side increases, it's going to push that diaphragm, the valve will be in one position. And then if whatever conditions or controls occur that pressure reverses, you're going to move the valve into the other position. These are very elegant. They have fewer moving parts than a lot of other actuators. And it's a very simple way to control a valve that you need to have very low failure rates in working. You usually have to put in a separate pneumatic system and like a control panel to make sure that that is moving the correct way, but they're very easy to use. Hydraulic actuators use a pressurized liquid, they move a piston, okay? These tend to be less easy to throttle with. That movement of the piston, it typically goes its whole distance of travel. And so it's typically in on or off. It's a lot less easy to do throttling than with an electric motor, okay? And then your solenoids, they have a magnetic slug attached to the valve stem, and they're going to put some sort of coil in the valve actuator that's an electromagnet, and it's just gonna move that up and down based on whether or not the electromagnet is on or off. And if you think about it, this is kind of simplistically the same way that the control rod drives work, right? It's just like a solenoid actuator. They use an electromagnet and they turn it off when they need them to drop, and then they're holding it otherwise, right? Okay. We've talked about this in drawings class, right? But we have fail open and fail close. So valves fail when they stop being able to be actuated, okay? Failing open means that when there is a loss of power signal and they can no longer be actuated, the power was essentially forcing the closed position, and so they're going to fail open. They're going to default back into this position they wanted to be in, that some part of the system was holding them from. So whether that's an electromagnet and then that solenoid, when it fails, you're going to pop open, or if it was a piston that was holding them in place, and when the electricity goes out, it now falls back and allows them to remain open. When it stops actuating, you're going to have that condition. Failing closed does the exact opposite, right? Coolant flow into the reactor, you are always going to need to fail open, right? There's not a circumstance where you want to be unable to put coolant into the reactor because your valve failed. Flow out of the reactor, except for some very specific exceptions, is going to be a failed close, because you don't want water being taken away from the core. You do, of course, still want access to your heat exchanger. There'll be some piping system where you don't automatically have failed close valves, but in general, you don't want down system leaks pulling water out of the core that you can't have a way to stop, right? And then, of course, if you have an accident that's called a loss of ultimate heat sink and you don't have access to that heat exchanger, then that's when you're going to want to close those valves and make sure that water isn't going where you don't have access to cooling anyway. So this was pretty short. I think you guys have probably covered a lot of these topics before. And that is all I had for us today. Any questions? Anybody online? Okay. Well, that was easy. This class is done. You guys will have your lab on Wednesday where you'll be dealing with valves. And it'll be a lot more, I think, interesting than just hearing me talk about the types and ways they can be configured. They actually get to see it. When Evan gives me the details, which will hopefully be this evening, I'll let you guys know if there's any change to the plan, but just plan on being in your group and going down to Evan's area on Wednesday. Okay, see you guys later this afternoon.